Using a non-uniform object as a bob would not be a good idea, because in that case, to find we cannot measure the exact length of the, or as if we cannot find out the exact position of the center of gravity within the object, and then the length calculation of the simple pendulum can prove to be much too difficult. Yes. Abdullah, তোমার কোশ্চেন আনসার পাইছো?
Yes, sir.
আচ্ছা, beautiful. আমি P4 থেকে কয়েকটা কঠিন কোশ্চেন আলাপ করতে যাচ্ছিলাম, দাঁড়াও বের করি আমি। এখানে অবশ্য লেবেল করা।
থিওরি নোটস কবে পাবো?
কি জিনিস?
থিওরি নোট।
থিওরি নোটস গুছানো শুরু করছি, একটু সময় লাগবে। আমি জানাবো তোমাদেরকে, আই এম ওয়ার্কিং অন ইট। আচ্ছা, এইগুলা যে কভার পেজ ছাড়া দিছি, তোমাদের কারো কাজ করতে কি ঝামেলা হইতেছে? ফর দোজ হু অ্যাট লিস্ট ট্রাই।
না স্যার।
মানে ইউ ক্যান ট্রেস আপ হোয়াট ইয়ার ইট ইজ ফ্রম হিয়ার, রাইট? এটা তো পুরো বুঝো, এই লেখাটার মানে তো সবাই বুঝো।
ইয়েস স্যার।
আচ্ছা আচ্ছা, এখানে আরেকটা জিনিস তোমাদেরকে বলি, সেটা হচ্ছে P4 এ যদি কোনো সময় এরকম কোনো একটা সার্টেন পয়েন্ট থাকে, মানে একটা ডায়াল দিছে, the capacitor is now fully discharged, the student reconnects the circuit. How much zoom can I make this? Wow, I can zoom this a lot. This doesn't break at all. Good. So let's say the question is asking us that what is the reading shown in this device, and এই device এর reading কত?
88
তারপরে এর হাতে 88
milliamperes
milliamperes বলা লাগবে। আচ্ছা, তোমাদের P4 এর জন্য কখনো যদি তোমরা কোন একটা সার্টেন মার্কিং পয়েন্টকে দুইটা ভিজিবল দাগের মাঝখানে দেখো, you are allowed to give that fraction value. মানে হচ্ছে, let's say if this marker was here, I cannot actually, if this marker was between two of these lines, so this would be one of the odd marking, because you can see that each of these division line actually represents two increment. So 80, 82, 84, 86, 88, and then 90. So if any of the if this marker, this pointer was in between two lines, then you should consider this as an odd measurement. Or so এটা অনেকগুলা কেসে অ্যাপ্লিকেবল হয়, অনেক সময় তারা হাফওয়ে মার্কে দেয়। If it is in the halfway mark, you read off it as a fraction of a division, and you can go ahead and give that reading. এটা এই কোশ্চেনের জন্য অ্যাভেলেবল ছিল না, বাট দেখে মনে হলো তাই তোমাদের সাথে আলাপ করলাম। আচ্ছা, এরপর এখানে আছে প্লটিং এ খুব ঝামেলা কিছু নাই। You guys do know about the purpose of this thing. Do you remember this thing?
Yes, sir.
আমি তোমাদের থিওরি ক্লাসে পড়ানোর সময় বলছিলাম, this is what we call a displacement can spout. The benefit of having a displacement can is that if you are trying to measure an object that is too large to fit within the measuring cylinder, a displacement can come in extremely handy. So if you need a full, you do use the object as it's supposed to be used. আচ্ছা, এটা একটা জিনিস বলি, সেটা হচ্ছে one way to make the experiment more accurate. এটার একটা অ্যাসপেক্ট হচ্ছে যে টিপিক্যালি whenever the মানে one of the most reliable way, মামুন hold on এক মিনিট। All right, I was ordering some food, my bad. So we are back. Acha, this is one way to make the experiment more accurate. To make any experiment more accurate, the primary way to go for is repeat and average. And you cannot only write those three words, repeat and average. এটা লিখলে তোমাকে মার্কস দিবে না। You have to go for minute detail for how that idea of repeat and average is applicable for this experiment. So what are you going to repeat and what are you going to average? You have to specify that. For example, in this question, we are trying to find out the frictional force on a block of wood sliding along a bench. So তাকে কিছু দেওয়া আছে, block of wood hook, newtonmeters with different ranges, 1.1 Newton, 0.5 Newton, 0.1 Newton weights and hangers, thin string, pulley, stand clamps and bosses. So idea is pretty simple. We're going to hang up a pulley over here on the side of the bench. We're going to give up a string around this thing. we're gonna keep the string taut, and then we're gonna apply the load slowly, and whenever we'll see the object is about to fall down, then we're gonna start adding 0.1 Newton close to that weight so that we can get a very close fraction. I mean, we're not gonna increase the load by 0.1 Newton. That would take a very long time. So, I mean, if I want to explain how I would do the experiment, this is how it's gonna look like. You guys do understand where the clamp is gonna, where the pulley is gonna be, right?
Sir.
On the edge of the table, we should have a pulley, and the string should run over the pulley, and eventually it's gonna connect it with the mass anchor. So the way I'm gonna do the experiment, I'm gonna use those 1 Newton weights. 1 Newton means 100 gram. 100 gram now, 0.1 into 10. Yeah, 100 gram masses. So I'm gonna keep adding those 1 Newton weights, and I'll find out a certain value of weight for which it actually starts to slide down. Let's say what I find out that this block starts to slide at 7 Newton, but does not slide at 6 Newton. Value mone rakho. Just taking some example, which means its frictional force is bigger than 6 Newton, but it is definitely smaller than 7 Newton. What I'm gonna do, I'm gonna reset the mass at 6 Newton, where the block of wood is not sliding. Then I'm gonna add the 0.5 Newton. If I add the 0.5 Newton, then I know and I'll observe the motion. If the block of wood does start to slide, it means now I know that the frictional force is between 6 and 6.5. It's a process of reducing the range. It's a process.
Could you repeat, please?
Yes, I'll start again. Mishkat, তুমি কালকে কালকে পাঠাইতে পারো, সমস্যা নাই। Adnan Sami, we are currently doing একদম পেজ নাম্বার 21, মানে একদম শুরুতেই আছি। হ্যাঁ, পেজ নাম্বার 21।
জি স্যার।
ঠিক আছে। মিশকা, তুমি কালকে কালকে কাটাতে পারো, লেটস সে সকাল 11টার পর। যাকে পাঠাও, তুমি লিখে পাঠাবা যে O levels paper 4 booklet and mark scheme, তোমার রোল নাম্বার, নাম লিখে পাঠাবা, and you will have it received. আমাদের কোচিং এসে বললেই হবে, আমার অ্যাসিস্ট্যান্টটা থাকবে, they can do it. বুঝছো? হ্যালো মিশকাত? আচ্ছা, okay. So let's say that at 6 Newton the block did not slide, at 7 Newton the block did slide. So I have to understand that the actual frictional force between the block of wood and the table surface is between 6 to 7 Newton. এই রেঞ্জের মধ্যে কোথাও আছে। Then let's say I want to exactly find out the exact value. So what I'm going to do, I'm going to reset the mass at 6 Newton, and the block is not moving, and I'm going to add 0.5 Newton. I'm not increasing by a smaller fraction. Now I'm going to do the observation. If after adding 0.5 Newton, the block of wood does not start to move, it means it is still stationary, then I have to understand the frictional force is bigger than 6.5 Newton. 6.5 Newton is not good enough to make the block move, which means friction is bigger than 6.5 Newton, which gives me an idea friction must be between 6.5 and 7. So I have to search within that range. And if the block of wood does start to move at 6.5, then I know that the frictional force is smaller than 6.5 Newton. So it must be between 6 and 6.5. Do you understand my point?
Yes, sir.
Yes, sir. So I'm now smaller. Then let's say if the block did not start to move from 6.5, which makes me sure that the frictional force is higher than 6.5, then I'm going to keep it at 6.5, and only then I'm going to start adding 0.1 Newtons in increments and find out exactly for what value the block of wood actually does start to move on. And that makes the whole number of steps much too easier. I mean, you do not want to start adding 0.1 Newtons from the very beginning of the experiments. This is going to take a huge amount of time, and you might as well run out of all the 0.1 Newton of weights before you actually reach even close to the value of frictional force. So using the large forces first, then find out the gap within which your actual aimed value lies, which is in this case the frictional force between the block and the table surface, and then you slowly lower the increment so that you can get a much more precise action close to that value, which works better. এরপর আমাদেরকে বলছে যে we have the pulley, stand, clamps and bosses. So এগুলা দিয়ে আমরা এই পার্টে সেট করে কাজগুলো করব। এখানে আমাদের আরো কিছু জিনিসপত্র এক্সপেরিমেন্ট that the student can use, আচ্ছা এগুলো বললাম। আচ্ছা এটা বলছেন just want to make the experiment more accurate. So how can we do repeat and average for this experiment? One thing that can always go by is that assuming we see the frictional force on the block sliding along a bench. So we can do this experiment in multiple ways. You should not assume that the block of wood is essentially have the same surface finish on all the sides. So one surface might be more smooth than the other. We should not preferably change the on a block of wood sliding on a bench. No, we should actually do this experiment in different places on the bench. For example, at one point you place the block of wood over here, in another place you place the block of wood over here, and in different places of the board. And you can also essentially do this experiment for 4 different surfaces of the block of wood. So you can do this experiment for these flat surfaces, for these thin surfaces as well. So you have 4 surfaces that you can pull along for the orientation of the block of wood. So to get a more reliable answer for this answer, that what is the frictional force of this block of wood and the table surface, we should preferably do this experiment for all the 4 surfaces one at a time and find out the average force that is required, and find out the average of those forces. So that's the full description for what you are trying to repeat and average. I'll say it again. We perform this experiment on different part of the wooden bench and for all the 4 surfaces of the block of wood, and average those values to find out the average value of the frictional force required. So specify what you are going to repeat and what are you going to average. That is very important. এটা হচ্ছে আমাদের যে কোনো এক্সপেরিমেন্টকে অ্যাকুরেট করার, to make the results more accurate or reliable, sometimes we also use that term, একটা খুব common উপায়. But only mentioning repeat and average is usually not good enough. You have to specify what you are going to repeat and what you're going to average. One more thing that I'd like to tell you is that precautions is almost always about a human precaution. In the process of doing an experiment, we never want a human being to become injured, whether that human being is someone who is doing the experiment or someone who is a collateral. For example, not doing an experiment, just passing by your experiment, and then something bad happens in an experiment and that person gets shot. So we do not want any type of human injury. For example, so in any experiment, you have to think about what kind of human injury is possible to happen in this experiment. For this experiment, the most common of human injury can happen is by falling loads. Let's say if you add too much load onto your mass anchor and there is not enough friction, that mass is going to fall down onto the ground. So if it falls on your feet, then you're going to get hurt. So wearing protective shoes is one of the primary required human precaution, and that's the first thing that I'm going to tell you. And then again, after you can think of all the possible human precaution, then comes the precaution about the equipment safety. Equipment safety means you should not do your experiment in such a way that your equipment can get damaged, so they cannot be reused. So for example, in this case, if we keep on dropping those, if we keep on adding bigger amount of load and eventually the whole thing starts to fall down, they might actually fall onto the ground and they might break the tile if there is some, or they might actually make a nick on the finish of the ground. The masses, if the floor doesn't get bent, maybe the masses are gonna get a bit of a compression mark on their side. So you're basically deforming the whole mass. That doesn't change the mass value, but that is basically damaging the equipment. So one logical thing can be that we can place a sand tray underneath those hang masses so that they are cushioned when they fall, if they fall. Or you can simply place a large piece of foam under the masses so that if they fall, they are cushioned. So that's one way to think about the equipment safety. So these are the stuff that I need you to think whenever you are answering solving the paper for question, that what is the human precaution that you can think for an experiment and what is the equipment precaution that you can think for an experiment. If that question is already asked in the question, you have the mark scheme to check your options. If that question is not asking not asking the question and you just thought about it and you would like to check me with them, write this down. Later in any other case before classes, you can always ask me that at the number page a question human precaution ki hobe ba hocche improvement ki hote pare. If you want to discuss about them, I can go for that as well. বুঝছো কি বলছি?
স্যার ইকুইপমেন্ট প্রিকশন গুলো আবার বুঝাবেন।
হ্যাঁ,
ইকুইপমেন্ট প্রিকশন আবার বুঝাবেন।
আমি এই এক্সপেরিমেন্টের জন্য একটা রিলেভেন্ট ইকুইপমেন্ট প্রিকশন বলছি, বাট দ্যাট ক্যান বি ডিফারেন্ট ফ্রম ডিফারেন্ট প্লেসেস।
স্যার এই এক্সপেরিমেন্টের জন্যই বলবেন।
Equipment precaution is about keeping the equipment in its original state, not destroying it or bending it or bulging it or deforming it anyhow. For this experiment, the most possible case that can happen is that the masses that we're going to hang over here, if we hang too much mass, this can overcome the friction pretty easily and it might fall onto the ground. That way your floor might get nicked, your masses might become a bit deformed and so on. So to make sure none of this happen, we can place a sand tray under the falling masses so that their fall can be cushioned, or we can use a large piece of foam under the hanging masses so that if they fall, they're gonna be cushioned. So in this case, the equipment precaution is about if the masses fall down, we have to allow it not to damage its own self or the floor surface. That's the equipment precaution in this case. বুঝছো? Okay. So that's that. The student repeats experiment wearing the surface area of the block in wood encounter demonstrate how the student does it with the same block of wood. Oh, I just said that here. He just rotates it. Achha, okay. F equals to cow. এইগুলো খুব কমন কোশ্চেন যে আমাদের টেবিল হেডিং ফিল আপ করতে বলে. Table headings are always to be filled up in a very specific manner. If you look at any of the printed table, you can always know what you are asked about. For example, if you have a look at this table, table headings are always to be filled in this manner. Symbol of the quantity, not the name of the quantity, not current in its spelling. Symbol of the quantity slash its unit, not essentially as a unit, the exact unit that you are gonna measure with or the exact unit you're gonna plot with about. So it doesn't have to be the SI unit. So I quantity slash unit, quantity slash unit. Which one in the first axis, first column, which one in the second column is usually not a very big deal. Usually not a very big deal. If the question doesn't specify that, you can pretty much put it anywhere, any of them in the any of them in anywhere. For example, the question where I jumped up from, this one says that a teacher says that the frictional force F is related to the weight of the block by the equation F equals to kW, where K is a constant. The student varies W by placing additional weights on top of the block and measures F. Okay, that's a pretty nice step to go for. So he's gonna apply different values of weight onto the block so that the W becomes larger and measures the K value. On figure 3.3, write the headings of the table used to record the results. So in this case, it's gonna be pretty simple. F slash N and then W slash N. So yeah, that can work pretty well. What I believe experiment one of the important detail that I actually forgot and it just popped in my head. This question has a Newton meter. Do you see that? In the list of apparatus, we have a Newton meter available for this experiment.
Yes, sir.
Which brings me to the idea that because we have a Newton meter available, it is very much possible that the calibration scale of the Newton meter might as well be smaller than 0.1 Newton, because it says the Newton meter with different ranges. Different ranges means you have to assume that you have availability from very small precision to very high precision. So measuring that force which is required to make this block move it might as well be a good idea to measure that force with a Newton meter. Now you might wonder, how can we connect a Newton meter over here? Let me show you a bit of a drawing for how it is possible to introduce a Newton meter for our apparatus setup. I'm going to try to draw a simple, go ahead for a simple drawing over here. Let's say this is the tabletop. And then this is the leg of the table. Wooden block. Let's say this is the wooden block. And here is the hook. We should attach a pulley so that the pulley actually, we should set the height of the pulley in such a way so that the string is actually running preferably horizontal. You can simply draw the pulley like this. Wheel comes in and then there is a wheel. The string runs over the pulley. comes down, and we can attach a Newton meter in two places. We can either attach a Newton meter over here, or we can attach a Newton meter over here. Attaching a Newton meter over here can prove to be slightly difficult because after it moves down a little bit, your Newton meter will keep on hitting the pulley. You might have dislocating the string. String ঠিক করতে দিতে পারে. So if you ask me, I would be preferably connecting the Newton meter over here. So that's actually vary from person to person, but if you can connect it in over here, or you can connect it over here as well. So I can actually connect the Newton meter over here. So draw up a rectangle with two hooks on two sides, because that's basically how a Newton meter looks, with a little bit of pointer at the center. We're going to label everything, so the quality of the drawing doesn't have to be that good, but this string is supposed to be a single straight line, so do not draw them with an angle like this. I'm drawing on a slippery surface, so bear with me. And then we have the mass angle. So then comes the labeling. Table, wooden block, string, pulley, spring balance, mass. So in this case, the benefit of this whole thing would be that we can essentially have it. We can attach those masses, and we can actually we might be able to find out the very small fraction value by reading off from this part, that exactly how much is the tension on this thing to make this whole block to move. Another part that I did forget to tell you is that whenever we are really close to finding out the value of friction, whenever we are pretty close to finding out the value of friction, one thing that we can do is that we can slightly tap on the table to see whether that slight tap actually makes the object to move. I mean, the idea of tapping is like this. Whenever the table and the block is completely stationary, try to listen to this pretty carefully. Whenever the table and the block are, both of them are perfectly stationary, they have a fixed amount of friction between them, which we usually call a static friction. But let's say you are pretty close to finding out the exact friction value for that surface and that orientation of the block, but you just want a really precise value. You just want to have an extremely precise value. So whenever you're pretty close, then you set up your value, and then you slightly tap onto the bench. The idea for tapping on the bench is that whenever we'll tap on the bench, the molecules which are in contact between the wooden blocks and the table, they're going to be slightly displaced because of the vibration. You're going to try to find out that whether that slight amount of variation is good enough for the block to start its journey. If that happens, then you should be really happy with your measured number. That is your frictional value. So what is happening that whenever for a static case, it is not moving, but this value that I'm set, if I give a bit of a vibration, then it is actually starting to move. The vibration actually helps to overcome the friction in the relevant components. For example, this vibration that you're going to slightly make on your table can help you to overcome frictions in two places. One place is this contact surface, this one, let me label that with red, this contact surface, and because you're going to tap onto the bench, and this clamp is pulley is also connected over here. This pulley is basically a pivoted wheel. So there is always supposed to be some friction between the wheel and the pivot, which we always consider to be negligible, but practically speaking, it is never actually zero. There is always some value involved. So whenever you're going to tap slightly onto the bench, you are going to help the apparatus to overcome that friction momentarily, giving your setup a chance to perform itself without the presence of friction for each of those taps. So that's where the tapping can come to. And tapping does not mean banging on the table. I mean, you're not going to hit on the table that everything starts to jump. No, tapping means tapping, slight tapping. So that can help to overcome the friction. That's also another important experimental variable for this thing. I think I forgot to mention that, but I just remembered that. So the spring balance might also be counted over here. We might actually take a look at the mark scheme to see what are the points that they have said. It's a pretty interesting question. This is May June 11, number Kotor A1, 3A1. Let's have a look. May June 11, question number 3A1. Suitable aluminum apparatus described on diagram reads meter or notes weight when weight adjustment. So they have mentioned both. You either read the meter or you may add up the weight, notes the weight, which means record the weight when the weight just moves. Sensible comment. Increase force slowly or adds weight gently. Use same part of the bench. Okay, so they're not averaging this part. Choice of Newton meter described. So choice of Newton meter described means that you should use a Newton meter that has small fractions on its measurement scale so that you can measure it very precisely. Repeat readings to find average. I have described that. String should be horizontal. I have also said that when I was drawing this thing. Check for zero error in the meter. This is a pretty important thing. I have never shown you a spring balance. But let me show you a spring balance. Zero error টা আলাপ করা যায়। Well, তোমাকে কথা শুনতেছো? None of you are giving me any sound, which is a pretty normal thing for online classes, but
Ji, sir.
pretty difficult thing to actually
Yes, sir.
Ji,
taking
sir.
a class on the teacher's counterpart. If you have any question, please do respond. যেগুলো বলতেছি বুঝা যাচ্ছে?
Yes, sir.
Yes, sir.
Ji, sir.
Images. Adjustment সহ কোথায়? I do not see a spring balance that we usually use, which has an adjustment button. This I think has an adjustment button. Okay, I'll have that in hand. All spring balances have some adjustment button, but sometimes they are visible, sometimes they are not. So this will actually do my purpose. Achha, never mind. এটা দিয়ে দেখাই। Have a look at this. This is one of the metal spring balances where we have a spring, and this is our sliding contact, which is gonna give us some reading. This knob that you can see on the top, this circular part that is coming out, this is usually like a screw, and you can have it visible in other equipments as well. For example, this one has a knob over here, not very clear, but they always exist a knob at the typically at the hanging end of the thing, which is not visible in this one at all. If I go up, this one, you see there is a different color of a thing, ring kind of thing over here. There is this green part over here. So it is always on the hanging part. I mean, not on the mass part, but on the hanging part, there is a knob. This knob works as your adjustment screw. This is very much similar to the adjustment screw that you can have on analog ammeters or voltmeters or in analog weight machines. For those of you, have you kids ever seen an analog weight machine that you stand
Ji,
up on
sir.
it and that you get dial rotates
Yes,
by?
sir.
Yes, sir.
Yes, sir.
Sir, what is that purpose of that switch?
It's বলতেছে analog আচ্ছা দাঁড়াও বলতেছে এক মিনিট ওইটাই আলাপ করবো দাঁড়াও একটু ডিটেইল একটা ফিগার পেলে ভালো হয় okay let's say this is a pretty detailed figure. So the idea is that over here we have Newton, over here we have gram, 9.8 1000 গ্রামে 9.8 Newton. হ্যাঁ ঠিক আছে, over here we have gram. F lexicon I'm not sure. Why did they write F over here?
Force.
Acha, gram force of British. Acha, never mind. This is gram. This side is gram. This side is Newton. Acha, boltese. The idea is that if we don't hang anything over here, this red mark should be perfectly aligned with zero on both sides. Now we can check it by you pull it by your hand a little bit, and then you let go of it slowly. See if it perfectly gets back to zero. Do it a couple of times. If for all of your repeated attempts, this red mark perfectly reaches to the 0 level, then you know that there is no zero error. The presence of zero error means that when nothing is measured, reading should be zero. That means no zero error. But if it so happens that whenever you are attempting to slide this by your hand a little bit and then you let go of it slowly, if this thing does not reach up to zero, let's say in some cases it goes up or it goes down, then you know that there is a bit of a zero error. what you need to make sure that before you actually hang anything at the lower end, this red mark should be perfectly aligned with the zero mark. That's what is the no zero error is about. So that's, and achieving this is can be called to be zero error correction. So we can do this by rotating this screw. Whenever we can rotate this screw, this red mark is gonna either move up and down. So without doing anything, there is actually an adjustment screw over here, and by rotating this thing, we can actually make sure that this red mark perfectly comes back to its original position. So that's important. Mucho.
So the purpose of the switch is to fix the zero error, if any.
Exactly. If any. So that's the important part. So check a zero error in meter. So I mean, check zero error means you should check for it, and if there is, you correct it. That's embedded in this part. Sensible comment on the friction over pulley. So friction over pulley, that can be overcome by either lubricating the pulley. For example, we can introduce that we use drops of oil in the pulley wheel to reduce the friction, or we tap onto that bench a little bit to slightly reduce the friction slightly. Average জন্য এই জিনিসটা বলছে b number also use different sides of the block of the same block. That works. আচ্ছা বাকিগুলো simple. I think that works out for this experiment. Simple experiment, but if you think for information, that details can actually matter. Number 4 says the student walks away from a street lamp at night and notices that his shadow changes. The student investigates shadow of a darkened laboratory. He uses a lamp on a stand and a vertical card, as shown in figure 4.1. On figure 4.1, draw a rate of light from the lamp to the bench, just passing over the top of the card. So you have to pinpoint the center of the lamp, and from the center of the lamp onto the touching this vertical card, you have to finish at that line over here. The region of the bench that does not receive the light from the lamp is the shadow of the card. On figure 4.1, draw a line on the surface of the bench to indicate the shadow. So you have to start from this bottom and draw up a line up to here to represent that shadow. Then the card is moved. How you question?
Sir.
Hmm.
Sir, October, November 11 একটা কোশ্চেন ছিল পেপার 4-1
111.
Yes sir.
আচ্ছা যাচ্ছি দাঁড়া। বলবান তোমরা যদি কোশ্চেন অ্যাটেন্ড করে থাকো, if you have certain questions about certain things, এই যে এইটা রিডিং কত হবে? যাচ্ছি আমি 1 মিনিট। আব্দুল্লাহ, এইটা রিডিং কত হবে বলো?
1.5 volt.
1.5.
এই জিনিসটা বলতেছিলাম যে মানে এই জিনিসটা বলতেছিলাম যে আমাদের মানে ডায়ালে যে রিডিং গুলো আছে, আমাদের মার্কারটা বা পয়েন্টারটা যদি তার মাঝামাঝি থাকে, we should consider giving fraction mark. So এখানে ডায়াল ভ্যালু গুলো হচ্ছে 0.2 করে, but since the marker is at the halfway point, so this is 1.5 volt. 1.5 volt is the correct response. আচ্ছা এটা হচ্ছে তোমার ইয়ার এক্সপেরিমেন্ট। কুলিং কার্ভ, এটা একটা ভালো কোশ্চেন। স্টুডেন্টরা খুব কমনলি এই কোশ্চেনে মার্ক লুজ করে। মোস্ট কমন মার্ক লুজ করার কারণ হচ্ছে দে either forget to label these two axes, or they don't label the two axes, or they label the axis in a wrong way, because axis labeling should also be happening with quantity slash unit, quantity slash unit. So here theta slash degree Celsius, t slash minute or second, whatever you write over here, minute or second, that you should mention over here. And there are two different test tubes over here. So both of the cooling curves should be decreasing gradient. One should be decreasing rapidly than the other. The one that is black, A should be decreasing more rapidly, so this should lose gradient pretty early, become asymptote earlier, and B should be becoming asymptote later. Yeah, good question. এই টাইপের কোশ্চেনগুলো অ্যাকচুয়ালি স্টুডেন্টদের অ্যাপটিটিউড টেস্ট করার জন্য অনেক ভালো। মানে the student really knows what the itsy-bitsy details of the whole thing, and definitely the concept of the whole idea, it can go along to check for it for a very good thing. Although not needed for this graph, one important addition thing that people can do, which they do not asked to, you can label a certain level over here as room temperature and make those lines as you get asymptote with the room temperature value. Because if you label this graph with 0 degrees Celsius, and you're cooling this experiment in room temperature, they are never going to reach to 0 degrees Celsius. They are going to reach close to the room temperature. So it would be a pretty nice and the sign of a good student is that you can label room temperature over here, mark up a dotted line, and make those graphs, cooling curves, get asymptote with that line, room temperature line, not with the 0 line, because that's not supposed to happen in a realistic scenario.
Sir,
Yes,
so asymptote হবে কেন?
because the hot object is going to slowly cool down, cool down, cool down, cool down. And the idea of heat transfer is that the smaller, the bigger is the temperature difference, the more rapid is the heat transfer. So if you bring two objects which have a very large temperature difference, they're going to exchange heat very rapidly. The further their temperature difference go down, or it means the 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 less temperature difference they have, they're going to exchange heat more slowly. So the rate of change of heat energy is sort of reversely related. I'm not going to using the term inversely proportional because I do not know for a fact if it is inversely proportional, but I can say it's reversely related. Reversely related means if one goes up, another one goes down. So the rate of change of heat between the two temperature different objects is reversely related to the temperature difference of the two objects. High temperature difference means rapid heat exchange. Less temperature difference means less heat exchange, which brings us to the idea that whenever a hot object is slowly becoming cooler and cooler and cooler, essentially it means that the smaller the temperature difference, the less is the heat transfer. So if you think in theoretical terms that it is getting closer to room temperature but not taking heat as much as earlier. So the closer it gets, the slower it takes heat. So theoretically speaking, it will take infinite amount of time to actually reach to that heat temperature exactly. বুঝছো?
স্যার তাহলে একটা হট অবজেক্ট কি জীবনেও রুম টেম্পারেচার রিচ করে না?
Theoretically never, practically yes, because at points that difference between those two objects become minusculely small, which we can consider to be negligible. So within limit of acceptable errors of the experiment, we can very well say that they are the same temperature. But if you think in terms of minute temperature variation, for example, let's say like we're not going to give any segue in our measurement. In that case, we can never say a hot object and cold object will ever reach the same temperature. Their temperature difference is going to become very small over time.
ওকে স্যার।
বুঝতে পারছি?
জি স্যার।
Right. আব্দুল্লাহ কোনটা বলছিল জানো? অক্টোবর নম্বর 11 এর 41 না 42?
41
41 এর কোনটা? কোশ্চেন নাম্বার
2B
এটা?
না স্যার 41 স্যার অক্টোবর নভেম্বর 11
এই যে 41 আসছে তো।
নাম্বার 2 স্যার এটা আপনি মনে হয় 1 এ আছেন স্যার 1 এ আছেন
আচ্ছা
এটা
কোশ্চেন
1
নাম্বার,
স্যার
আচ্ছা কোশ্চেন নাম্বার 2
ইয়েস স্যার
এটা।
হ্যাঁ স্যার হ্যাঁ 2B
আচ্ছা আমাকে কোশ্চেনটা একটু বোঝার চেষ্টা করি। কোশ্চেনটা বুঝলে তাহলে আমাদের কোশ্চেনটা বোঝা হবে। কোশ্চেনটা দেখো সবাই। A straw balance is used to measure the mass of a length of hair. Wow. Sure, why not? So figure 2.1 shows the straw balance. So we have a U-shaped box thing. We have a needle that is supporting a paper straw, which is very light. We have a flattened end on the side on which we are gonna place, I believe, the that thing, the hair, and we have a small screw that is screwed into the back side. The straw is flattened at one end and has a small screw inserted onto the other end. A needle is pushed through the straw to balance the straw on a support. When a mass is placed on the flattened end of the straw, the end moves down. The larger the mass, the more it moves down. The distance moved down is directly proportional to the mass. Okay. The height of the flattened end is adjusted by moving the screw into or out of the straw. State what happens to the flattened end when the screw is moved into the straw. State what happens to the flattened end when the screw is moved into the straw. If the screw is moved into the straw, then this side moment is gonna become less. This side moment is gonna become more. So the flattened end will drop down. আচ্ছা তোমার প্রবলেম ছিল বিতে না?
ইয়েস স্যার
The flattened end of the straw is placed in front of a vertical scale marked in centimeters. with nothing on the flattened end, it points 0 on the scale as shown in figure 2.2. আচ্ছা ভালো কথা. In order to use the straw balance to measure mass, the scale can be marked in grams, which means that we want to, this is basically what calibration is. This thing that we have over here is what calibration is. So we have a pre-marked centimeter scale because it is available to mark it from a printer, from a ruler, you can mark it very easily. But we want to use this same calibration or same division lines, but we want to translate this information into grams so that we can take measurement in grams as well. So calibration, the primary way to do a calibration is that you have to first set up the device in a precisely known value and mark that thing. Then you should be slowly going onto the other side. So what we are gonna do, I mean, this was achieved for a certain position of the screw over here, and now nothing is moving, the straw is stationary. So what we can do, we can place a very small mass over here, maybe let's say 5 gram or 10 gram, but the mass of which we know very precisely. We might as well take that object and measure it on a digital balance to know its exact mass very precisely. And then we're going to place it over here and allow the whole thing to come to stationary at a certain point onto the scale. Then we're going to mark that value with that much scale, or with that many grams, and divide all the divisions in between with equal number of gaps for relevant amount of masses. For example, let's say we're going to place a perfectly 10 gram mass over here, let's say, and then this mark drops down to, let's say, 4.2. Let's say I might as well steal this picture out of here. So let's say this is the scenario. So here we have placed the scale over here, and let's say we are gonna place exactly 10 gram mass, and then this thing, this flattened end of the paper straw gets perfectly aligned. Let me zoom in a little bit, maybe. Should it help? Yeah, this helps better. So let's say in that case, this flattened end becomes aligned with the 4.2. So if it is aligned with the 4.2, then I should know that this much is how much? 10 gram. I can label this thing as 10 gram. Half of that should be 5 gram. Half of that should be at where? 2.1. Now I do not have 2.1. So I can mark, give a new mark. So let me do it with a sharp line because I don't want to mess it up. So we can give a mark like this, exit at the halfway mark, and label this as 5 gram. And we can keep it as is. So if you wonder that, do we need to give all the other marks? Well, you can, or you can skip it. If you wonder that if I skip it, then how am I gonna do in the measurement of the hair? So here comes the part. Now you know that for a 10 gram mass, this end goes down by how much? It goes down by 4.2 divisions or 4.2 centimeters. This is your known information. This is a calibration information.
আমরা unitary method use করতে পারি?
Exactly. Beyond this point, we're going to use unitary method. So if I reverse this information, 4.2 centimeter is relevant for 10 gram. So let's say now you're going to replace this 10 gram mass and place the hair that you want to measure, for which you want to measure. Let's say that after placing the hair, let's say it has gone down to, let's say, up to here. So let's say it is now at the halfway point between this mark. So you count, what is this value? 1, 1.2, 1.3. So now you can directly go for 1.3. So 1.3 centimeter relevant to how much? So 10 multiplied by 1.3 divided by 4.2. You can very easily get the mass of the hair by that calculation. So calibrating would essentially mean marking on the scale your expected scale. বুঝতে পারছি?
Yes, sir. Proportional বলা ছিল থেকে এটা ইউজ করছি না?
Exactly. ডিরেক্টলি প্রপোর্শনাল বলা ছিল বলে আমরা ইউনিটারি মেথড ইউজ করতে পারছি। যদি ডিরেক্টলি প্রপোর্শনাল বলা না থাকতো তাহলে ইউনিটারি মেথড ইউজ করতে পারতাম না। Unitary methods are only applicable whenever your certain relationship is directly proportional. বুঝা গেছে?
Yes, sir.
তোমাদের জন্য রাখো। আচ্ছা। হয়েছে? Acha. So let's go look at the question and see what the question has for us. The student places a 2 mm square of graph paper on the flat end of the straw. The end of the straw goes down. Thank you. The end of the straw goes down as shown in figure 2.3. So now currently it is at the halfway mark of koto. Eta kotote ache? 1, 1.2, 1.4, 1.5. Exactly 1.5 division আছে. So the reading on the scale. Reading হচ্ছে 1.5 centimeter. The graph paper is now removed and the length of the hair is placed on the end of the straw as shown in figure 2.4. So now it has come to here. So the new reading on the scale, this should be 3.8, I believe. Yes, 3.8. The student is told by the teacher that the piece of graph paper has a mass of 0.30 milligram. Calculate the mass of the hair. So 1.5 centimeter relevant to 0.30 milligram, and then interim method করে এখান থেকে তুমি এটা বাইরে করবা. Such one
Basically a unitary method, right?
Yeah, simple interim method, nothing else, nothing complicated. Such one advantage of a straw balance when compared with an electronic digital balance. আচ্ছা, straw balance এর বেনিফিটটা হচ্ছে
Much more accurate.
I would say it has a very high sensitivity. I mean, it is definitely accurate, but why is it accurate? It has a very
Because
high
of the sensitivity to measure very small values.
Exactly. This will give us a visible amount of deflection, even for the slightest change of mass. This end is gonna have a movement, even for the slightest amount of mass, which you might not have for your digital balance, because your digital balance is calibrated for a certain amount of measurement. It cannot measure up to fractions of milligram. You can see that somehow the teacher have measured that piece of paper has a mass of 0.30 milligram, which required a very precise top end balance. Typically, the top end balances that we use in our laboratories can measure up to 2 decimal places in grams. So measuring 0.3 milligram would require a very special digital balance, which is usually not available and might as well lose its precision. But this one is a visible way, and it is very sensitive to very slight change of mass. So how am I going to write this answer? I just described. So I'm going to write that a straw balance is very sensitive to the slightest change of mass, making the measurement much more accurate. Now, if I look for the mark scheme, this was ON11 number 2D. তোমরা কি এক্সাম ইনস্টিটিউট পড়ো আদত?
Yes, sir.
যারা পড়ো না তারা পড়া শুরু করো। একবার পড়া শুরু করলে তুমি বুঝবা যে কেন এটা তোমার জন্য খুব বেশি দরকার. You'll get to understand that. If you don't understand that, you ask for help. I'll help you understand that. 1D. না, এখন তো মেজুন 11 আছে। কত নম্বর কোশ্চেন দেখলাম মাত্র? 2D, ON1141. ON1141, 2D. No electricity needed, cheaper, easy to build, more sensitive, precise. আচ্ছা, ওরা অনেকগুলো different benefit বলছে. Mentioning any of them would do. I would definitely go for the more sensitive part. But no electricity need is also a good thing. But then again, how would we know that first value of the 0.3 milligram in the first place without electricity?
Sir,
Yes.
আর আমাদের সিলেবাসে কি অ্যাডভান্টেজেস এন্ড ডিসঅ্যাডভান্টেজেস অফ রিনিউয়েবল এন্ড নন রিনিউয়েবল এনার্জি সোর্সেস আছে?
তাকে একটু ওয়েট করো। advantage. Ano? দেখো এখানে কি কি আছে on D option it precisely says least renewable and non-renewable energy resources. It has no mention of the advantages or disadvantages, so I would say no.
Yes, sir.
হ্যাঁ তাকে কি যেন বলতেছিলা
স্যার আপনি যে বললেন যে স্ট্র ব্যালেন্স বেশি প্রিসাইজ হবে স্যার, স্যার এটা কেমনে স্যার? লাইক একটা মেকানিক্যাল জিনিসটা কম প্রিসাইজ হওয়ার কথা স্যার ডিজিটাল জিনিস থেকে?
No. Mechanical or digital is not the actually key factor between a precision. It's about how you operate this device. বলতেছি a digital device measures the mass, digital measures the mass by means of a piezoelectric transducer. A piezoelectric transducer is something that you haven't come across. এটু থেকে পড়বা. A piezoelectric transducer is basically a piece of a silicon crystal which can give you a voltage output across its two sides whenever pressure is applied to it. Basically, every microphone, each and every microphone works with one of these piezoelectric crystals. So whenever I talk through it, the compressions and rarefactions of the air particles vibration creates a certain pattern of pressure variation. That exact pattern of pressure variation is converted into voltage variation, which is read off from the microphone wires and then amplified, and then that comes as the voice. Weight machine digital balance pretty much works with the exact same principle. Now the thing is, you have to measure that voltage precisely. The more precisely you can measure that voltage, the more sensitive your digital balance can be to smaller weights. Typical balances that we have available in our laboratory, they have a typical maximum range of 1000 gram, and usually they are able to measure up to 0.01 grams typically, which means the voltage, the voltmeter, which is going to be measuring that the voltage across that piezoelectric crystal, is precise up to a certain value. This device is more precise because of its construction type. For example, have a look. We have placed a needle over here, and we are using a small screw to calibrate the alignment first. The friction that you have involved is only at the contact point between a very light needle and this thing. This entire thing is made up of a paper straw, which means the weight of this whole setup is also very small. And this end is significantly longer compared to this end. And we're going to place the object over here. So this is what makes the all of these features, lightweight, small contact points, and longer loading side, makes the visibility for the for the going up and down of the flattened end much too easier compared to a digital balance. For example, we can measure the mass of a hair, one piece of hair of this much size using this balance, but for a typical digital balance that you have available in your laboratory, this would prove to be very, very difficult. I mean, you would require highly precise digital balance, which are not very common in all typical O-levels, A-levels laboratory, to be able to measure the mass of a hair. You cannot usually measure the mass of a hair, but for device you can, because it actually is designed in such a way. Lightweight, really small contact point, and a large arm representing the deflection. বুঝতে পারছি?
জি স্যার। স্যার একটা জিনিস স্যার,
বলো।
স্যার কিছু এক্সটার্নাল ফ্যাক্টর আছে, যেহেতু এই পেপারটা অনেক লাইট স্যার, এটাকে যেরকম উইন্ড তো একটু বা স্মল এয়ার এগুলোতে এফেক্ট করতে পারে স্যার এটার ক্যালিব্রেশনটাকে?
Yes. We should prefer to do this experiment where the table setup is stationary, there is no vibration, and there is no dot in the room. We should be definitely take care of this thing. More precision, more reliable method can be that we should have what can I say, transparent plastic cover around this setup so that wind flow does not make this vibration go around. Or also another thing is that we will only take readings when the straw is perfectly stationary. So if the straw is making a bit of a movement, we should not take the reading. We should allow the setup to become stationary, and only then should we take the reading. These are all recommended precisions. Yes.
Okay, sir.
আচ্ছা
আর কোয়েশ্চেন পেপারে যে সমস্ত এক্সপেরিমেন্ট গুলো করব একটাও কি কমন আসবে আমাদের সময়?
well it would not be it you shouldn't expect an exactly identical question because CA don't do that, but the content and the design are similar.
Yes, sir.
Wait a minute, I'm having dinner, so not dinner, I'm having lunch plus dinner, so I'm sorry.
অর্ডার করা
যেটা হচ্ছে যে মনে করো এটা একটা সার্টেন এক্সপেরিমেন্ট ছিল, দিস ইজ এ ভেরি ইউনিক ইকুইপমেন্ট, so this exactly same equipment might never show up in your experiment ever, but the ideas that you are using over here, the idea of the proportionality calculation, the idea that why this setup can be more precise, which I discussed, these ideas can be applicable in other relevant cases. And now how do you find out that relevance is defined by your amount of perception and practice? That's basically what you will be divided into grades after your result comes up. So for example, here you have a CRO calculation, you have some reader from the CRO. So you might, in another question, you might have a similar figure where you might have to read a different thing with different Huygens and the time-based settings. So if you know how to work around these stuffs, getting a different reading is not a difficult thing. They are not identical questions, but they are similar questions. That's what I mean.
Yes, sir.
Okay. এগুলো তো আচ্ছা, এই ড্রয়িং গুলো নিয়ে একটু আলাপ করা যায়। সিআরও তো তোমাদের রিসেন্টলি পড়াইছে, এইটা নিয়ে একটু আলাপ করা যায়। কোশ্চেন নাম্বার 3টা আমরা দেখি। I'll wide up the page so that it is visible for a better part. Most of you have the question papers in your hand. For at least for those of you who do not have it yet, can you read the full question side by side? Is it possible to read this thing?
Yes, sir.
আচ্ছা, এটা অ্যাকচুয়ালি রিড অফ করতে না পারলে সমস্যা নাই। আচ্ছা, might as well keep it in the original fashion. সমস্যা নাই। দেখি, a cathode oscilloscope is used to check the voltage of a cell. Figure 3.1 shows the cell of a simple circuit and also the front of the CRO. So we have a cell, we have a resistor, we have a 0 point. Okay, the CRO is switched on and the time is switched off. A bright dot is seen on the screen and in figure 3.1. State switch controls are used to move the dot to the center of the screen. So এখানে বলছে হচ্ছে এখানে কোনো কিছু কিন্তু কানেক্ট করা নাই। So the CRO is just switched on and the timer is switched off. And the moment you turn it on, it is showing up here, but it is not supposed to be here. The instant that you turn on the CRO, where it is supposed to be? Just turned on. Nothing is connected.
সেন্টার
It's supposed to be here. So you're supposed to first take it over here, and we have to use these two controls, X shift and Y shift, to move it up over here. X shift is going to move it horizontally, Y shift is going to move it vertically. So you have to adjust both of them to bring it up over here. So you just write that over here. State switch control, X control, comma, sorry, X shift, comma, Y shift. You have to write both of them because currently this dot is deviated in both sides. Left সরে গেছে, bottom সরে গেছে. If it so happen that this dot was located vertically below this axis, মনে করো হচ্ছে this dot is supposed to be here, but in a certain question they've placed the dot only vertically below. So they've placed this dot over here, that CR has turned on and the dot showed up over here. Which control is supposed to be used?
So
If
Y
it-
shift.
in that case only Y shift, তখন তুমি আর X shift লিখবা না। বুঝছো কি বলছি?
Sir, at the first place এমন মানে চেন ডিসপ্লেসমেন্ট হলো কেন, এটা এমন কোশ্চেন আসলে কি লিখবো?
এটা reason based question আসার possibility খুব কম, but still since you asked I can tell you the reason this kind of deflections are usually seen on the CRO, preliminary deflection. Primary reason is that আমরা CRO মনে করো একটা CRO তে আমি কিছু এক্সপেরিমেন্ট করলাম, এক্সপেরিমেন্ট করার পর আমার মনে করো এক্সপেরিমেন্ট করা শেষ। এখন আমি যেটা করলাম এটা হচ্ছে যে আমি এই গেইনগুলোকে জিরোতে না এনে মেইন যে পাওয়ার সুইচটা দিয়ে CROটাকে রান করতেছেন সেই পাওয়ার সুইচটা অফ করে দিলাম। পাওয়ার সুইচটা অফ করে দিলে কি হবে? আমাদের CROতে এখন আর কোনো এক্সটার্নাল পাওয়ার নাই, হুইচ মিনস এক্সপ্লেট এবং ওয়াই প্লেটে যে ভোল্টেজ গুলো ছিল সেই ভোল্টেজ গুলো কিন্তু এখন মানে the amount of charges, I'm talking about actual electrons shortage or actual electron excess, এক্সপ্লেট এবং ওয়াই প্লেট গুলো যেগুলা the charge that was stored in certain plates, they are still there. They could not get removed. They could not become neutralized because you have switched off the power supply while this thing was still located in one of the gain points. If we do that, let's say we turn this on and then we unplug the device and then we casually bring it to zero and store the CRO device. The next person who is going to start doing this experiment, the moment they're going to turn it on, that stored charge, which was initially over in your plates, is going to show you some deflection. This is the most common reason why you might have a deflection at the beginning. It was একটা part. And the other part that can be, this problem that you're seeing is basically a version of zero error for CRO. What do you mean by zero error? That nothing is applied to the input side, but the display is showing you some reading. It means zero error. When it is supposed to show you zero, it is not showing you zero, means there is a zero error. So that zero error can also develop in a CRO over an extended period of time. For example, if certain capacitors or resistors within the CRO device which lost functioning, you can have a continuous show off of this zero error at the beginning of every turning on. It is possible to develop from within the circuitry of the CRO device over a extended period of usage. That is also possible. I cannot exactly highlight what kind of problem actually caused this kind of problem, but this is also one of the reasons that I know for a fact. বুঝে গেছে?
Yes, sir.
আচ্ছা, তো এটা গেল। On figure 3.1, draw connections from the circuit of the CRO so that the voltage can be measured. So voltage measure করার জন্য আমাদের সেলের থেকে দুটো কানেকশন এনে আমাদের ওয়াই ইনপুটের দুটো কানেকশনে ঢুকাইতে হবে। তুমি সেলের দুই পাশ থেকে নিতে পারো, রেজিস্টারের দুই পাশ থেকে নিতে পারো, এখান থেকে নিলে হয়েছে, বিকজ সেলের দুই পাশ থেকে নাও আর রেজিস্টারের দুই পাশ থেকে নাও প্র্যাকটিক্যালি একই জিনিস, বিকজ there is only one cell and one resistor connected over here, so it really doesn't matter. So এখান থেকে একটা নিয়ে এখানে দিবা, একটা নিয়ে এখানে দিবা। আচ্ছা, যেহেতু একটা জিনিস বলি, because this Y input does not have any plus or minus labeled over here. This is an important discussion to try to understand. I'll have to copy this picture to draw stuffs. MS Paint একটা কাজের জিনিস।
আচ্ছা স্যার, এটা কোন ইয়ার স্যার?
এটা MS Paint।
9
আচ্ছা
না
আচ্ছা,
স্যার,
সরি,
মানে কোশ্চেনটা খুঁজে পাচ্ছি না স্যার বইয়ে।
কোশ্চেনটা আছে হচ্ছে তোমার বুকলেটের পেজ নাম্বার 36 এ।
পেজ নাম্বার, ওকে স্যার, এখন দেখছি।
স্যার,
ইয়েস
স্যার ওয়ার যদি ইন্টারসেক্ট করে তাতে কোনো সমস্যা নেই?
সমস্যা নাই, বাট if it is unavoidable, preferably avoid that, but কোনো সমস্যা নাই। So what I'm trying to mean is that এই ডিভাইসে তুমি যেখানে কানেকশন দিলে হবে, left or right doesn't matter, but if it so happened, hold on, try to understand my word, if it so happens that Y inputer একটা certain কানেকশনের পাশে গ্রাউন্ড একে দেওয়া আছে, one of the Y input connections is labeled with a ground. In that case, you are always supposed to connect the low voltage of your supply to the ground connection, and the high voltage should be always connected to the other one. This is the typical way we prefer to operate the CRO, so that it is the reading usually comes on the top side, so that positive readings are considered as positive reading, negative readings are read as negative reading. So if this was given already in the question, then I would preferably draw it this way. So I would preferably use a low voltage side connection to this one, and the high voltage side connection to this one. You see, if I could have drawn it from here and do a bit of an overlap and eventually come over here, that would still be all right. But I intentionally connected it from here because I for reasons unknown, wanted to avoid the disconnection. You can draw hand-drawn lines like this, or if you want, you can draw ruler lines like the line. You can use rulers as well. I mean, rectangular wires. The quality of the line really doesn't matter, but if they ever cross, an overlap should not have any lump. Make sure there is no lump. So don't touch it. That's the way.
স্যার
Yes.
আমরা বুঝবো যে এই হাই ভোল্টেজটা কোনটাতে লাগাতে হবে আর লো ভোল্টেজটা কোনটাতে?
যদি আমাদের y ইনপুটের কোন একটাতে গ্রাউন্ড কানেকশন লেবেল করা থাকে, the ground connection should always be the low voltage one and the other one to the other one. The ground level input should always be the low voltage. এখন তুমি এখানে আমাদের ওয়্যারে দেখো, এটা হচ্ছে আমাদের ব্যাটারি, তাহলে এটা হচ্ছে ব্যাটারির পজিটিভ সাইড, এটা হচ্ছে নেগেটিভ সাইড। তার মানে এই পুরো ওয়্যারটা হচ্ছে হাই ভোল্টেজ ওয়্যার আর এই পুরো ওয়্যারটা হচ্ছে লো ভোল্টেজ ওয়্যার, তাই না? সো তাহলে এই পার্ট থেকে যাবে হচ্ছে গ্রাউন্ডেডটাতে, আর অন্য ওয়্যারের যে কোনো খান থেকে তুমি দিবা হচ্ছে অন্যটাতে। বলো
স্যার আমরা কিভাবে বুঝবো যে এখানে কোনটা হচ্ছে করা গ্রাউন্ড করা? এখানে
এই কোশ্চেনে লেবেল করা নাই, সো এই কোশ্চেনে তোমার কানেকশন ম্যাটার করবে না, তুমি যে কোনোটাতে কানেক্ট করতে পারো। In certain scenarios, this can be labeled. If it is labeled, then the discussion will be irrelevant, which is not available here. But in some questions, it might show up. Yes. So let's go forward. এক মার্ক ছিল। Yes. বলো।
স্যার যে লো ভোল্টেজ যেটা একটু আগে বলেন স্যার, ওটা কারণ আমাদের জানা লাগবে?
না, you don't essentially need that.
Sir?
Yes. বলো। Yes, বলো।
জি স্যার। আমি কানেক্ট করি লো হাই ভোল্টেজের, ওখানে হাই ভোল্টেজ ওয়্যারটা স্যার, ওটাকে আমাদের কেন জানা লাগবে?
না, কেন বাটা জানা লাগবে না, এটা কোনো জিনিস করবে না। But the reason I usually do this is because whenever we connect it in that pattern, positive voltage show up on the positive y-axis. So that makes the calculation part a bit simpler. But it's not essential to do that. But that is something that I have seen in some years mark scheme to promptly show up that is preferred by the examiners. Alright, এখানে বলছে হচ্ছে the dot is now at the center of the screen. Figure 3.2 shows the dot on the screen of CRO before and after the cell is connected. So it is here, it is here. Use figure 3.1 to state what is represented by 1 centimeter vertical of the axis of the CRO. So এখানে আছে হচ্ছে 2 তে, so 2 volt per centimeter. So 2 volt, you're going to write 2 volt, both the number and the unit, you have to write both. Remember the voltage of the cell.
Sir, 2 volt কে বেশি এটা বুঝেন।
এই যে এখানে দেখো, take a read off. Where is this knob located at? 2.
Yes, sir, 2 volt. But is it after that? I mean, when the point shifts upwards or before, sir?
Questionটা পড়ো। This is about the scale of the figure, not yet movement. That vertical axis every single centimeter কতটুকু volt represent করে, irrespective of the position of the dot. Number 2 is about the position of the dot.
Okay, sir.
বুঝছো? আচ্ছা, সো এখানে বলছে determine the voltage of the cell. এখন voltage of the cell তো আমাদের কোনো ডিরেক্ট মার্কিং এর উপরে নাই, সো এটা মেজার করা আমাদের একটু ডিফিকাল্ট হতে পারে, বাট here is the deal. What is interesting that this grid is actually of 1 centimeter size. Take up a ruler and hold it against this line and look at the measurement and try to find out that how much is this part with respect to the whole.
1.5 to 2.
This should locate at exactly 0.75. This is the center of the
একটা
dot.
কাজ করতে পারি না যে ওই এটা মেজার করে we will multiply it with 2 to find the actual voltage. Unitary method.
That is exactly what I'm proposing that you should do. But to do that, you have to use the ruler. I was just trying to describe how to use the ruler. That's it. But yes. So,
Yes, sir.
if you hold up your ruler against that line, you'll see that that dot happens to be at the 0.75 mark. Do you see that?
Yes, sir.
And now I know this because I've solved this question quite a lot of times. That's why I know this. And also I don't have my book and paper over here. So which means this is 3/4 of 1 centimeter. So the measured voltage should be also 3/4 of 2 volt, which is 1.5 volt. So in this case, you do not have to show any calculation because this is only 1 mark over here. You can just write up over here. But if you still want to show the calculation, you can directly write over here 0.75 into 2 equals to 1.5 and then write 1.5. Just to be just for some additional practice, because you are now learning how to do this stuff. So if this question did have 2 marks over here, the calculation would be expected to be seen. Because it is a 1 mark question, the calculation is not essentially required for this question. So that's that. Describe and explain what is observed when the connections from the circuit to the CRO are reversed. So
Then
yes,
the answer করবো
হ্যাঁ বলো।
sir same position but below the same distance from the race but below the bottom level.
Exactly. The
Dot will show up on the opposite side with same displacement.
the dot show up on the opposite side on the same displacement. Exactly. So it is over here. And describe and explain both say. So that is the description. So what will be the explanation part?
Terminals are reversed.
Terminals reverse already bole dise. Explanation will require some physics-based explanation.
Current flows in the opposite direction.
Sir, এভাবে বলতে পারি না, when the voltage is reversed, the electron excess and electron deficiency occurs oppositely. So the electrons moving charged particles are deflected towards the opposite direction.
That is actually a very precise and very nice explanation. But one thing that is missing from the explanation is the Y plates. If I was writing this explanation, I would write it in this manner. Hear me out. I might be wrong. I'll look at the mark scheme to see if I'm wrong, but I'm gonna give it a short verse. I write it in this manner that the dot will show up below the x-axis at minus at 0.5 centimeter. The dot will show up 0.75 centimeter below the x-axis. Full stop. Because the Y plates inside the CRO are now oppositely charged. I would write this much. So let's have a look. This is
শুধু ইয়া দেওয়া explanation
111.
দেওয়া নাই explanation দেওয়া নাই তো শুধু just dot moves down.
হ্যাঁ তোরা ডেস্ক্রাইব এক্সপ্লেন বলে তাহলে 1 মার্ক দিছে কি জন্য? এগুলো তো খারাপ। ডেস্ক্রাইব এন্ড এক্সপ্লেন দুইটা কোশ্চেন দিছে, এখানে তো 2 4 মার্ক হওয়ার কথা না। বুঝছো কি বলছে?
Yes sir.
141 D1. Dot moves down, not to center. Dot moves horizontally. Bah. Three na hai 3 D1. A majority of candidates thought incorrectly that the spot such dot would return to the center of the screen. All that was required the candidates was to state that the dot would move down. Oh, bah. মানে শুধু move down এটুকু লিখলেই মার্কস দিবে। The more able candidates stated that the dot would move down as far below the center as it was initially above. Okay. This is basically what we opted for. We are more able candidates. Good. Again, only the more able candidates realized that the dot would move horizontally across the screen or that a straight line would be observed. Many candidates stated incorrectly that the wave should be displayed on the zero screen. No. Acha, but actually, I mean, question na dekhai answer dekhe because this is actually pretty simple. That's why I did not go for it. But if I was trying to write the reason in the simpler words, simplest form of words, I would write the reason that because now the Y plates are Y plates inside the CRO are oppositely charged or reversely charged. You can also use that word. That will be my version of the explanation. Sabi, তুমি যেটা বলছো ওটা perfectly ঠিক আছে, but you just did not mention the Y plates. It is important that you mention those words because the plates are basically what the distinction point is about. বুঝছো?
Yes, sir.
Beautiful. Question number 4 is about drawing. Yeah. Drawing এর জন্য কিছু খতরনাক ফিগার আছে, এরকম একটা খতরনাক ফিগার বের করা দরকার। তুমি খতরনাক মানে বুঝো?
Dangerous.
Not accurate.
খতরনাক মানে হচ্ছে বিপজ্জনক। At least I don't. আমি তাই জানি। I believe I'm correct. দাঁড়াও।
স্যার বিপজ্জনক হয় কিভাবে স্যার একটা ফিগার?
একটা ফিগার বিপজ্জনক হয় যেখানে ভুল করার অনেকগুলা জায়গা থাকে। যে তুমি যদি একদম
মানে আর্টিস্টের জন্য
paramount level cautious না হও। I mean the content that you're supposed to do for the figure is pretty simple. But there are so many places that you will either misread the question or you're likely to misread the question, or you read the question right, understand it wrong, or even the precision of your figure will lead you to a certain amount of deviation from the measurement that is going to cause you to lose mark. So there are so many different places where you can be wrong. You can be wrong in any of these places to score full marks of this question. This is the kind of question that is dangerous. বুঝছো? আচ্ছা, এখানে একটা জিনিস তোমাদেরকে দেখাই। This is actually one of the very interesting experiment. It just popped in, so I'm showing this to you. I'm taking a bit of a jump, but don't be worried about this. এখানে আমরা যে কাজটা করতেছি, we are performing extension experiment for a certain piece of wire. Have a look at the setup. We have the clamp, we have wooden blocks, we have a piece of length of the wire over here. Somehow we have measured this much. Actually, we have given a load over here. A bit of a load is initially given over here to make sure that the wire is perfectly taut. This is called the dead load, which we do not measure. Under the effect of this small amount of load, the wire is taut, and then we use a meter rule to measure how much is this thing, and then attach a piece of paper which is going to work as a reference for extension. Then we have put the meter rule over at the below, and then as we are going to slowly add load to this thing is going to extend, and then the paper marker is going to slowly move to the right. This makes the observation far too easier, but here they have made a little bit of mistake, in my opinion. That mistake being, other than using a rectangular marker like this, they could have pretty much used a pointy marker, which should have shown them a much better observation. What I mean by a pointy marker is something like this. Let me give you a bit of an example. এটা কি তোমাদের আগে দেখাইছিলাম?
স্যার রেক্ট্যাঙ্গুলার মার্কার আমরা ইউজ করব, আমি বুঝবো কিভাবে মানে কোন পয়েন্টটা হবে আসলে?
এটা তো বুঝবো না। এটা বুঝবো না দেখে আমি পয়েন্টি মার্কারের কথা বলতেছি। আমি পয়েন্টি মার্কারটা কিরকম হলে ভালো হয় সেটা একটা एग्जांपल তোমাদেরকে আমি দেখাইতেছি। হোল্ড আপ। What I would prefer
something like a prism, স্যার।
কি কি বলছো বুঝি নাই।
একটা প্রিজম দিয়ে মার্কার এরকম
না, it's just a piece of paper but that has a bit of a sharp corner. For example, something like this. Let's say we use a paper piece that is slightly above the ruler to avoid any friction, and then we make this corner. How about our tape looks like this? So if we have a tape that looks like this with a very sharp corner, I can now take the measurement far too easily, because with a rectangular piece of paper type like this, there is a far too big possibility for parallax error. Don't you think?
Yes, sir.
There's a far too
Yes,
big
sir.
possibility for parallax error, but whenever you use a marker that is a bit pointy, then you can pretty much get away with that. And have a look at the shape. I have not chosen a shape like this. I have chosen a shape like this because I wanted this much to be my preferred length. So that's pretty important.
Why, sir?
If I wanted to give it a marker that has a shape like this, then my required amount of length of wire that I'm judging at the initial value should be, and that L, I mean that L that is measured over here, that L that is measured over here should come to the center of the marker. But here you can see that the L is measured to the left edge of the marker. That's why I have.
Oh, now actually.
বুঝেছে? আচ্ছা, so এটা গেল এখানে. This was a relevant discussion that just. I'm trying to find out interesting optical figure. This is also a pretty good optical figure. Drawing this figure is actually not a very difficult thing, but some people can prove to you. There is a certain figure that I'm trying to show you because optical figure showed up. Is it this one? No, this is actually also easy. Drawing optical figures are actually quite simple, if you ask me. This is a representation of the zero error. Do you kids see this?
Yes, sir.
Yes, sir.
Nothing is connected. Pointer is not zero. It is showing outside, lost. So you have to adjust this somehow to get rid of that error.
ওই সামহাউটা স্যার আমাদের জানা লাগবে না
জি বুঝি নাই।
স্যার ওই সামহাউটা স্যার আমাদের জানতে হবে না স্যার যে কিভাবে বাড়ি মেরে বা কোনোভাবে জিরো ঠিক করব
না বাড়ি মারি না, বাড়ি মারলে তো ডিভাইস ফেটে যাবে বাবা।
এটা কারেন্ট অপোজিট ডাইরেকশনে যাচ্ছে দেখে তো অন্যদিকে রিফ্লেক্ট করতে পারে
না, কারণ অপোজিট ডিরেকশনে গেলে অন্যদিকে ওইটা হচ্ছে কোনো কিছু কানেক্ট করা নাই, ওই কন্ডিশনের এরর ওটা দেখাইছে। কোশ্চেন এটা বলেই দেওয়া আছে, কোশ্চেন বলে এটা পাবা যে নাথিং ইজ কানেক্টেড, মানে জাস্ট ডিভাইস হাতে নিছো দেখা যাচ্ছে এই অবস্থা। আচ্ছা, অ্যানালগ মিটার কেমনে ঠিক করতে হয় আমি দেখাচ্ছি, ছবি বের করে দেখাচ্ছি, জাস্ট সেকেন্ড।
স্যার ট্যাপ করব
ট্যাপ করলে ফ্রিকশন ওভারকাম করা যায় মোমেন্টারিলি, জিরো এরর না। দেখা গেছে আমি 1 মিনিট। এই যে দেখো, এটা মনে করো হচ্ছে একটা অ্যানালগ অ্যামিটারের একটা ডিসপ্লে। এটা তোমার 30 অ্যাম্পিয়ার পর্যন্ত মেজার করতে পারে, সো রিয়েলি স্ট্রং মেজারমেন্ট। ওরা জিরোর একটু নিচে একটু মেজারমেন্টের জায়গা রাখছে, যে কেউ যদি রিভার্সে কানেক্ট করে ফেলে তাহলে এই ডিসপ্লেটা নিচে চলে যাবে, তখন মানুষের বুঝতে হবে যে তাহলে আমার কানেকশন ভুল হয়েছে, I have to reverse the connection to get the deflection on the right side. That's why they have kept a little bit of space on the negative side, just to show the people that you are messing up, reverse the connection. Here you can see a small screw type device which can be sometimes rotated by finger. There are it has screw kind of edges on the side, knurling, or it can also be rotated by a screwdriver. There is a vertical section over here. This is the adjustment screw. Does the exact same job like the spring balance. So if you rotate this in one direction without any connection, it's gonna slowly move. So you have to rotate this slowly, and eventually bring it up over at the zero position. Once you see it in the zero position, then you slightly tap on the device to see does it actually stay on the zero position or not. That's your fine tuning. If you see it does, move on. Your device is done. If you see it doesn't, then you readjust it and then again slightly tap the device to see that when there is no friction, even after a bit of a vibration, does it still stick on the zero mark? If it does, well and good. If it doesn't, then you recalibrate it. So for this device, you have this kind of thing. The typical devices, analog meter that we have in our laboratories, if you ever come to use it, you're going to have a thing like this, where this is your adjustment screw, which can be changed by a screwdriver. This is the adjustment screw.
Could you repeat the tapping part again?
Let's say you have adjusted for the first time and you have visibly brought the pointer to the zero mark. Then you should tap the device slightly to see that if it sticks on the zero mark. If it does, good. If it doesn't, if it has moved after a bit of a tapping, if bit of vibration, if the pointer does not stick to the zero mark, then you need to readjust it and tap it again. So trial and error, and eventually you need to make sure that even after a slight bit of tap, that pointer still remains on the exact zero mark. That's when you're perfectly corrected the zero error.
Sir, বুঝেছি যে we need to tap it for being sure, but what do we do if it moves after tapping? আবার বলবেন?
We rotate the wheel, rotate the knob to bring it zero once again.
Repeat until it is fine, right?
Exactly.
Sir, what does negative voltage mean? current flowing in the
Sir.
opposite direction?
Yes, I guess. Yes.
এখানে স্যার কোশ্চেনে বলছিল when the student closes the switch he notices the voltmeter needle moves downward.
হ্যাঁ, তাই নাকি? তাহলে আমি
হ্যাঁ
ভুল
স্যার,
করে দিয়েছি।
স্যার এটা বলতে পারেন যে পোস্ট মানে টার্মিনালস গুলো রিভার্স হয়ে গেছে।
হ্যাঁ, ইয়েস। আচ্ছা, আমি যেটা দেখা যাচ্ছিলাম সেটা হচ্ছে এই জিনিসটা দেখা যাচ্ছিলাম এখানে কেন আসছিলাম? আচ্ছা, ভোল্টমিটার অ্যাডজাস্টমেন্ট দেখানোর জন্য। আচ্ছা, আমি খুঁজতেছিলাম হচ্ছে কি খুঁজতেছিলাম? ডিফিকাল্ট
স্যার
অপটিক্যাল ফিগার।
ডায়াগ্রামস
স্যার এই লেন্সে ঝামেলা হয় একটু।
এখানে কি নাই একটাও নাকি এগুলো সব আগের ইয়ারের কোশ্চেনে চলে গেছে? হ্যাঁ, এই বুকলেটে কি লেন্সের ফিগার নাই? আইড বি হার্ট ব্রোকেন। এখানে এত বড় একটা জিনিস কেন? ওরে সর্বনাশ! এই কোশ্চেন দেখো, স্টুডেন্ট determines the difference of a glass of a semicircular block. The student is the relationship this much. You have to write the whole experimental setup in your own words and you get a total 5 mark for this along with the figure as well. Shit! এই টাইপের এক্সপ্লেন আসলে তো শেষ।
কোন ইয়ারের স্যার?
বুঝতেছো এই কোশ্চেনটা কেন ডিফিকাল্ট? It's not মানে it's not content wise difficult, but I personally hate this kind of long questions because it's difficult to score 5 out of 5 in these questions. It also imagine 1541. Damn, you really have to highlight this mark. Okay, read federal experiments from the book, otherwise you'll be in trouble. আচ্ছা, এটা CRO কোশ্চেন, ভালো কোশ্চেন। টম দিয়ে ধরতেছে গ্লাস বিকার। I'm looking for a very specific question which I cannot find here, so it might as well be on the earlier years, which is a shame because I did not give you a printout. এগুলো তো নাই, so I have to go out in my older PDF bundle to find out that question. দাঁড়াও, দেখাই দিছি তোমাদেরকে। আমি কি দেখাতে যাচ্ছি বলতেছি, কেন আমি এটার জন্য সময় নষ্ট করছি সেটা দেখলেই বুঝবা। একসময় কি পরিমাণ কাজ করতাম, আর যে মনস্টার। আচ্ছা, এখানেও তো এটা না, গোল একটা সার্কুলার একটা ফিগার আছে যেটা এই যে এটা, আহারে এক ইয়ারের জন্য মিস হয়েছে। S1042। আচ্ছা, এখান থেকে দেখাই তোমাদেরকে। বলো না, এই কোশ্চেনটা দেখো। আমি নেক্সট লিখে পরে ফিগারটা আসবে। এই কোশ্চেনটা পড়ো। A student performs an experiment using optical pins to find the effect of a circular block made of transparent plastic on parallel rays of light. Figure 4.1 shows a circular plastic block on a sheet of white paper. The student draw round the block with a sharp pencil. The student also draws 3 parallel lines up to the block before starting the experiment. Explain why the student draws around the block. It's pretty simple. For every optical experiment, we have to draw around the medium so that in our experiment, if ever the block gets moved or shifted by a little bit, we can replace the block in its original position and continue with our experiment. That's very important. The student places pins P1 and P2 on line 1, representing an incident ray of light. So, এই হচ্ছে line P1 and P2. He placed 2 pins at P1 and P2. It shows 1 incident ray of light onto the circular glass block. This is a circular glass block. Describe how the student places P1, P3 and P4 to locate the emergent ray. Describe, 1 mark. So, the answer is that the student looks from the other side of the circular glass block, looking at the level of the paper. It's important. Just normally আকাশ বাতাসের দিকে তাকালে হবে না, to look at the level of the paper and places his eye such that P1 and P2 appears to be on the same line. or you can write, in other words, P1 appears behind P2, or you can write P2 covers the vision of P1. You can write in all sort of different words, but they all mean the same thing, that they appear on the same line. And then the students places P3 and P4 in such a way that all of those 4 lines appear to be in the same line. এখানে একটা ইম্পর্টেন্ট জিনিস হচ্ছে যে in any optical experiment, we use 2 pins to represent 1 ray. These 2 pins necessarily need to be placed really far away from each other. They shouldn't be really close to each other. So preferably always 1 pin needs to be placed pretty close to the reflection medium, which in this case is the circular plastic block. The other pin needs to be placed close to the edge of the paper. The in-between gap between the 2 pins, as per CIE, is recommended to be at least 5 centimeter. The gap should be equal or more than 5 centimeter. Bigger than 5 centimeter, better. But less than 5 centimeter is not appreciated. So this is another important aspect for pin placing. It's important for you to know how to do the experiment. So let's go back for this one. Complete the path of the ray along line 1 to the block. Draw the normal at the point where the ray along line 1 enters the block. Measure the angle of incidence of I where the ray along line 1 enters the block. So আমাদেরকে কি কাজ করতে বলছে বুঝি। এই রেটার ফুল প্যাথটা ট্রেস করতে বলছে। This is pretty simple to do. I'm going to show you. Then এখানে একটা নরমাল রাখতে বলছে, এই পয়েন্টে একটা নরমাল রাখতে বলছে কার্ভের উপরে, and then incident angle measure করতে বলছে. So how can we do that? Let me show you. No.
আমরা P3 P4 মধ্য দিয়ে একটা স্ট্রেট লাইন আঁকবো যেটা সার্কেলের একটা জায়গায় কোইনসাইড করবে, and then we'll draw a straight line to that point and the point where line 1 meets the circle, right?
Precisely. I'm trying to do exactly that. I hope I can do that properly. I chose a sharp line to can you see the line that I'm trying to draw? I have chosen the sharpest of the options, but can you see that? Can you see this?
Yes,
line? Everyone, is it visible in your screen?
Yes, sir.
Yes, sir.
Or should I go for this one? I think this also works, right?
Yes, sir. This works.
This also works. This is has the almost the same thickness as the drawing. Okay, so I'm going to first draw this one, and then I have this cross point. Then I'm simply going to join these 2 points. So one starting here to here. This is the total path of the ray passing through the semicircular glass block. Be careful to join them properly. This is my one track. And then the question says I have to draw a normal over here. Now drawing the normal in a circular plastic block is actually pretty simple. All that you have to do is draw a radius onto this point. You don't have to essentially draw the whole radius. If you want to draw the whole radius, well and good, no big deal. You can draw this whole thing, or you can also choose to draw a fraction of it. For example, a fraction of it means, let's say, you are going to draw only this much. But what I would recommend that even if you want to draw half of it, extend this line by dotted lines showing that it is coming from the center. That will make the examiner understand that you know what you're doing. Don't draw this normal by eye measurement. I mean, it's not supposed to be eye measurement because you are gonna try to measure the angle. And then you're asked to measure the incident angle. The incident angle is pretty simple to measure. You hold up your protractor. In the proper way. Proper way means randomly protractor ধরে measurement করা try করবা না। যেমন এখানে একটা জিনিস দেখো, this line you could choose to make this pretty long, or you can choose to this line to be very small, drawn to this much. এখন কিভাবে protractor ধরলে তোমার angle measurement easier হবে? You can try it a lot of different ways. If you ask me, the way I would place my protractor, let's say protractor হচ্ছে এতটুকু বড়, so I'm gonna place my protractor in this fashion. This is how I would measure my angle for this question. Here is my 0 point, because I can see this line is really long, but I did not draw my line to be really long. So I'm gonna make up this point, and I'm gonna take reading of this point from the 0 scale, and that basically is my incident angle. So এই পার্টটুকু খুব একটা ডিফারেন্ট না। এরপরে বলছে হচ্ছে এই সেম কাজটা আমাকে লাইন 3 এর জন্য করা লাগবে। আমরা কোশ্চেন
IRR টা একটু মেজার করে দিবেন?
I cannot measure from the screen.
Sorry sir, I meant label.
Oh, in this case, this is the I, the angle between the incident angle and the, yeah, and this is the R.
Yes sir.
আচ্ছা, আমি কোশ্চেনটা একবার দেখাই। এখানে এটা ছিল কোশ্চেন। এখানে বলছে হচ্ছে, আচ্ছা এটা গেল, explain why a ray along line 2 passes through the block without changing direction. This is pretty simple. Explain why a ray along line 2 passes through the block without changing direction. So why the line 2 does not change the direction? How do you answer that?
It
Perpendicular to
passes
the
through the
surface.
center.
Passes through the center of the block.
Sorry,
is
sir,
basically-
no, not center, sorry. মানে ওয়ার্ডটা ভুলে গেছি স্যার। মানে
The reason any ray of light does not bend as it changes medium is because when the incident angle is 0, or in other words, the ray enters the second medium being perpendicular to the surface. So I would recommend you write that. Ray to line 2 or ray 2 enters into the circular plastic block and leaves out while being perpendicular to the surface. You should and you can give a semicolon and write it passes through the center of the circular plastic block. Because if it passes through the center of the circular plastic block, that's just a visible observation that you can make from the figure, which essentially makes sure to tell us that it will go undeflected. আচ্ছা এটা গেল, এরপর কি আছে? On figure 4.1, complete the path of a ray along line 3 through the block. এখন আমাদেরকে এই ফিগারে এই লাইন 3টা এখন কমপ্লিট করতে বলছে। এটা এখন কেমনে কমপ্লিট করবা? What is your proposed way to most easily? Yeah, it would be a mirror image. So what is the most convenient way to draw that?
স্যার আমরা একটা নরমাল আঁকবো and draw it at the how should I put this? স্যার আগে আমাদের নরমালটা আঁকতে হবে, then we will measure R. দিয়ে ওই দিক দিয়ে আমাদের যে we need to extend the line through the
Beautiful. Yeah, what Sabir proposes should perfectly work, but there is an easier way. Let me tell you this. Can someone propose that? I want everyone to
Sir.
participate. Yes.
স্যার লাইন
Please.
2 থেকে স্যার ওই যেখানে স্যার এই যে P2 থেকে P3 লাইনটা ইন্টারসেক্ট করে স্যার সার্কেলের সারফেস, ওখানে কম্পাস দিয়ে মেজার করে ওইটা ঠিক উল্টা সাইডে পয়েন্ট প্লেস করে কানেক্ট করে দিব।
You're saying this much is going to be measured.
উইথ আ কম্পাস,
Okay, with a compass.
পর স্যার উল্টা সাইডে দিব অন্য
And
পয়েন্টে,
then we label the point here. And then,
এন্ড স্যার কানেক্ট করব স্যার P3 এর এন্ডটা কোডের সাথে।
আচ্ছা তারপর
তারপর
you have to make it go outwards as well.
সেম P3 এর সাথে করতে পারি।
মানে এখান থেকে P3 হয়ে এই P3 ভিতর দিয়ে?
না স্যার, P3 আর ওই যে ওই লাইনটা স্কেল দিয়ে মেজার করব, পরে উল্টা সাইডে আবার ওই সেম লেন্থ দিয়ে আরেকটা ডট দিব, সেম P4 এর সাথে করে দুইটা ইন্টারসেক্ট করে দিব।
ও আচ্ছা, মানে এই লাইনটুকু মেজার করব?
জি স্যার, উল্টা সাইডে দিব।
Why not we simply join through this point? Isn't this a symmetry point?
ও ইয়েস স্যার, হ্যাঁ
বুঝছি বলছে?
জি স্যার।
আচ্ছা, so what Taki just proposed, and I added something as well, which in my opinion is the easier way, but
An
but
easier
if you
method would be placing a glass in the diameter and then tracing the line.
how does that work?
I mean, sir, I saw this in AQ that if you just put a glass in front of an image, and you can easily trace the image and copy it
Okay, that's essentially what I'm trying to
by
explain how to
taking the
achieve.
difference
So if you ask me,
on the glass.
in my opinion, the easiest way is that you measure how much is this. Either you can do it by ruler, or a more precise way would be if you go for a compass. So you measure how much is this one and give a dot over here so that you get this reference point, because you do understand that this dotted line is basically the symmetry line for the whole figure. What you're trying to achieve is a perfectly 180-degree mirror image of this original line. So measuring this point is good enough. So once you have this point, and this is also the intersection point over here, so the remaining part is pretty simple. You simply draw another line starting from here that goes to this intersection point and extends further beyond. This, in my opinion, is the easiest way to draw the line 3, in my opinion, without measuring any angle. You just do one measurement, that is, you find out the position of this point, and that's basically it. Everything else is given to you. So that's one thing. And another image that I would like to discuss, which I have over here, just took my eye, is this one. This happens to be which year? This is May June 07, question number 2. আচ্ছা, এগুলো আমি আগের ইয়ারগুলোতে পড়াইছি, তো ওই জন্য আমার এই কোশ্চেনগুলো মনে আছে। What I believe যে আমাদের নতুন ইয়ারেও আরো ভালো ভালো কোশ্চেন আছে, সো I might actually go through them. আমি এর আগে স্টুডেন্টদেরকে পড়াইছি হচ্ছে লাস্ট ইয়া পর্যন্ত W14 পর্যন্ত পড়াইছি। W14 এর পরে এই তোমাদের ব্যাচে এসে নতুন করে আবার কম্পাইলেশন করলাম। সো এর পরে ইয়ারগুলো আমার খুব একটা করানো হয় না। সো we can actually do this together. You can try it. You come across some problem, you ask me. We'll take help from the marking examiner and come to a discussion. No big deal. But next class, I'm going to discuss this problem. This is also a pretty interesting problem, which actually goes on to prove that if we rotate our mirror by a certain angle, our reflected ray actually rotates by double the angle, which was a theoretical proof that I gave you in your theoretical class for waves. You can turn up your earlier notes and find this out. You should be able to. But this is an experiment related into that. So where we have to follow some simple instructions and go ahead and to measure this as well. Bolo.
স্যার স্যার 9:30 তো বেজে গেছে, এটা কি স্যার নেক্সট ক্লাস ডিসকাস করা যাচ্ছে?
হ্যাঁ, এটা আমি নেক্সট ক্লাসে ডিসকাস করব, সেটা আমি বলতেছি যে I'm going to pick up this one in the next class. Well, one, thank you very much for today's class. We'll pick up this class. আমি লেকচার একটু আপলোড করে দিতেছি, আর হচ্ছে তোমাদের নোটসগুলো প্রিন্টিং এর কাজ আমি করতেছি। আমার গুছানো নিয়ে ঝামেলা হইতেছে কিছু। I'll let you know when you can collect all of these stuffs. It's going to be pretty soon. Yes, বলো।
স্যার, আমার পেপার 1 এর কোশ্চেন পেপারে একটা সমস্যা ছিল, দেখা দিবেন?
আচ্ছা, ঠিক আছে, আমি রেকর্ডিং স্টপ করে দিচ্ছি।